So when I was doing MBC, the question the Derek asked was, why don't we use inheritance? And I answered the question to some extent, and I want to answer the question properly. Okay? So we're going to talk about delegation, but it's really another way of saying that inheritance is considered harmful. Okay, so I told you that I'm going to teach you inheritance first. I'm going to tell you why it's bad. Okay? And this seems all wrong, right? We spend so much time on inheritance. We've seen a real use for inheritance. We can reuse code. So, now we are going to badmouth it. But, this is not always. It's indiscriminate use of inheritance considered harm. Okay? So you don't want to use inheritance always. And we're going to try to figure out, when to use it and when not to use it. And this is like, the analogy I was thinking of this morning was that it's like, you have a headache and I tell you, hey, take some aspirin. And it works really nice. And then I give you a whole lecture about when not to use aspirin. Okay, if you have an empty stomach, use something else. And that something else is delegation. Okay, so we'll see that delegation is the answer to inheritance. When inheritance is not what you should use delegation. Okay, and this is not to say that delegation is always to be used. Okay, if you, aspirin has its advantages. So it'll thin your blood, for instance. So we'll go and see again, when to use what. And this is something we do a lot in computer science, by the way. We first teach you something, then say a long list of warnings after that. This is don't use it. Sometimes don't use it at all. We first teach you something, and then we say don't use it at all, and sometimes we say don't use it in these circumstances. And the first big example in the history of computer science was something called GoTo. How many of you have seen GoTos? What languages? Sorry? Oh, BASIC has GoTo? So, you guys had a choice. That you could have done without GoTos. I was an engineer undergrad, I had to study Fortran. So this is something we lived on. And, they required cleverness and hence were very cool. And, engineers are real men, right? They don't take all kinds of pain. So what's the problem with GoTos for those of you who use GoTos? Roger?
It lets you jump all over the place indiscriminately. So really you're not thinking about making your program have, nice, neat, functional, logical structure. It's not good. Everything's like already just go, oh, I need to jump over here, and do something to figure out where the hell to go.
Okay. You may still be able to figure out. Somebody reading the code has no idea. Okay? And I didn't realize this, but a very smart guy, I knew this guy did this, Dijkstra, in 1968, that I didn't realize till yesterday, wrote this seminal article, GoTo's considered harmful. This is, see where I got my inheritance considered harmful from. Okay? And people, as smart guys are often, they ignored him for a long time. And then, there were languages that had GoTos, but said, don't use it. Okay, for all the reasons that I've mentioned. And this cartoon basically shows that if you use GoTo, all hell will break loose. Okay? So this is, this was a great language, but GoTo's were supported. But people still weren't 100% convinced you could get rid of GoTo's completely. There were still enough diehards who wanted GoTo. Okay, but finally, Java took the bold step and said no GoTos at all in the language. Okay, so no hell will break loose. So this is something we haven't really covered in class. But in class, have I told you something and told you don't use it besides inheritance? Sorry? Instance of, that's true. I told you use it, and I'll tell you later not to use instance of. Anything else? Or in an object in Java, have you been told not to use certain things in Java? Not by me, maybe, by your previous classes. You get a real, your knuckles slapped if you do some. This. What is the biggest no-no in object-oriented programming that Java lets you do, but you should never.
Properties directly, like through an object, like saying, like the object name dot the property is equal to something else as opposed to the getter set it.
Public variables, exactly. You're not allowed to declare that. Java will let you do it. Someday somebody will take a bold step and not allow public variables, but they're too scared to do it right now. It's stupid, I think. Okay? But a lot of you didn't even know there were public variables were allowed because your teachers never told you that language. It was a new speak in Brave New World. We won't even teach you bad things, or bad what we consider bad. And even I did it, right? I first taught you about classes. I said, unclass is cool. You can use a class as your own type. You're not restricted to ints, bools, floats. You can have a BMI spreadsheet as your own type, an abstract data type. That was so cool. And a couple of lectures later, what did I tell? And you could type variables using that. And now what do I tell you? You must use interfaces to type. Okay? Yes, you can type variables using classes, but don't ever do it. And again, I wish somebody would take the bold step in an object-oriented language and say you will not be allowed to declare, to declare variables with classes. And that will. I myself cheat a lot of times. And I wish somebody would stop me from cheating myself, and certainly it'll help in classes, okay? So that's the same kind of thing we are going to do with inheritance. So why do we use inheritance? Well, inheritance supports code reusability, right? You've seen that in your project. Is it the other way around also? If you want reusability, you should use inheritance? We started studying inheritance because I gave you an example and said, look, this code is repeated. And I said, hey, I can avoid the repetition by using inheritance. So I saw that inheritance implies code reusability. Question is inheritance the only way to get code reusability? That is when you
could just have stronger modularization. You just have very small classes doing very specific things and then not have to use it.
Okay, you're on the right track, but supposing I've got a class A that repeats the functionality of class B. Okay.
What class are you?
So supposing there's class string history, and I'm going to create a string database. Okay, so a string database can inherit from string history. Or what can I do? You can have two classes, a string database and a string history. They don't have an inheritance relationship between them, but what do they have between them? I can break things into small classes, but ultimately I still want, like fixed string database things. What do I really do? Supposing you didn't have inheritance, and you've got a string history, what might you have done?
You should make another class that just calls the other one.
Just calls that one, or doesn't call. Classes don't call each other.
Instantiates it.
Instantiate it, has a reference. Okay? So inheritance is a. I have put some class that is a special case of another class. Now I'll have a class that has a link to the other class. So this implication is not true, okay? Because you've got the notion of delegation with has a, which also implies code reusability. So that's the big point to be made in this whole thing. Okay? And here's a pictorial representation of this. So you can inherit things, like inherit genes. And the word delegation, as the English word says, you delegate. You don't do the work yourself, you pass the buck. So you do it. And there are good ways of doing it and bad ways of doing it, which is what is it. Now, based on the example, we know that inheritance and delegation are comparable. But based on this picture, isn't it like apples and oranges other than Tylenol and aspirin? Delegation is you're giving work to somebody else. Inheriting is you're inheriting traits. Do they have anything in common, really? What's in common? Just think of the abstract idea. Are they different things, or is one an alternative to the other? Sorry? Different things? Supposing you're not born with Ty Lawson's genes. What do you do then when you're in the team?
You get instance variable and Ty Lawson.
You pass to him. Right? You just become a good manager. That's what good managers are. They don't know how to do anything, so they just tell others to do it, right? So you can inherit your basketball skills, or you can pass to someone who has the skills. Right? Now, if you had a choice, which would you choose? Sorry? Yeah, but then you might have a tendency to sort of jam your toe a lot, you know. What do you do then? I see you're injured quite a bit with your soccer. Yeah. So, but having is good. I don't have to find a Ty Lawson. I'm him, right? So Ty Lawson, having that is much more less work. Okay, but if Ty Lawson is not performing well today and Danny Green is, pass the ball to him. Okay, that is the punchline here. Inheritance is less work. Delegation is more flexible. Okay, so that we'll see various ways in which that happens, but that's basically what's going on. Okay, so let's just make this what I just said. Okay, let's make it easy now. That was all making your brain tired. So if you guys remember the point history that I actually defined earlier, when we were doing points, if add element did not quite conform to the add element in history, it took an x and y as a parameter, and that point add element takes the whole point as an argument, which means this can be easily called with object editor. You just pass x and y. Otherwise, you got to somehow construct an object, pass it to object editor, which is the thing. So suppose, yeah. Okay, so let's try to figure this out. You're going too fast. So let's figure out the problem. So I would like to be able to somehow use my history in defining this point history. Now tell me how. So somehow in point history and somehow in the implementation of the point history, I want to use my generic history class and my generic history interface. So I go and change my history there. I go and put another add element here. Okay, so firstly, that class is something I may not be able to change. Secondly, what does that mean in the context of strings? What does that add element method do when I go and want to, because this is a very generic history. Okay, so I can't just, yeah.
Does that not mean that your history type, say, as you said, string, would now need an add element in text?
Yeah, that's what I'm saying. We don't want that solution. Okay, it doesn't make sense for anything but. So I'm stuck with this. Now I have two choices. I can either say, hey, forget this add element, let's redefine point history, or I can say, I want this add element, and I'll just forget about history, the interface, history, the class, and just implement my own class and interface from scratch. If I give you these two alternatives, can you tell me something in between that will allow me to reuse some code but not all, and how would I do it? Yeah.
First, implement the interface, and then also implement another interface that has this specific add element method that overrides the.
So remember, an add element method with x and y will overload and not override.
Could you create an interface that extends?
So I could extend.
And then when you have your add element with x and y, you can call the super add element that creates the new point.
So something like this.
Yeah, exactly.
Point history extends the history. Okay, and I just add my new add element with Cartesian point. Okay. But this is not quite what I wanted, right? Now this makes practical sense. But let's just say, for the sake of argument, that point history did not have an add element that took point as an argument. Suppose I don't want that. Suppose. Okay. This is like your scanner example. You had a scanner that returned a string property, and I want to replace that string property with the tokens property. I don't want the old string property to be around. Sorry, so what should I change here? I say point history extends a history. I don't like the extension because I get everything. Inheritance means I can't just go and say I don't want this from the parent. Okay, so my solution to it would be, yeah.
One interface is just element class and style,
Yeah, yeah.
More specific methods.
Good, good. And then my class, my implementation of the class, my point history would be what?
It would extend the interface.
No, it doesn't extend interface, it implements interface.
Interface with add X, Y,
But then I have to implement from scratch. I want to share some of the code in history, somehow. Extension is not working. Yeah.
You could create a partially functional history with abstract that has everything except that add method.
So then I have to redo the add method.
Yeah, and then you have an add method for point history and an add element for all the other history stuff,
Okay.
which technically could incorporate a history type thing.
So I haven't reused the add element method the same way that I'm reusing here. So how about that level of reuse? Now, supposing first, just to make something artificial, I can't change a history, let's say. But to make it more natural, more practical, I really want to use the add element method there. I want to go and check whether something, I'm adding to a full history or not. I don't want to redo all the checks in this add element. So when I want to reuse code, I can reuse code either by inheriting or by that's also inheriting. Before you guys had inheritance, copy and paste, something in between. When you were creating all your avatars, I said, be good and reuse code. In fact, there's a reason why we didn't allow inheritance among the assignments, because I wanted you to learn that you can reuse code without inheritance also. Sorry? Encapsulation hides things. It just prevents you from doing bad things. Sometimes it prevents reuse, actually. But just in this problem, did you finish your full thought when you were trying to answer this? No, I'm talking to Katie. Okay, Jack, what are you going to say? Good. So I am using a method within a class, right? So.
Well, I mean, like, method within a course. But more, maybe I don't think that documentation.
So you could make a class, a point history, which implements point history, which does not extend any of the, and then has as one of its instance variables a history, and then call for each of the variables the content.
Just, now that you've got this hammer, we forget about, what we could have done before inheritance. Before inheritance, this is what you should have done. You would define a history variable inside it, okay? And you would do your add element here, where you would say contents.add element, and then you have to go and define this forwarder methods that are doing nothing else but forwarding the call to something. Okay? So now the relationship between a point history and history is not that of is a. A point history is not a history. A point history, what relationship does it have to history? Has a. It has a variable of that type. Okay? So this is called delegation. Okay, so a manager delegates to the assistant. The manager is not a assistant. Okay? So the manager can go and say, do this task, and when the assistant comes back and say, no, I'll modify this, and this is what I'll present. You have some flexibility. Whereas when you inherit, you just get everything. You have no choice. It's all or nothing. Okay? So that's the word here. So we're delegating rather than inheriting from the class. And delegation is not a new concept. It's a new term to distinguish it from inheritance. And this is what we had to do. Then we had all these avatars. You had an avatar of one kind, delegate to an avatar of another kind. You had these links, and you were composing objects together. When you were composing, you were reusing.
Now, as far as it seems like in this case, you're gonna make a class at compile time, runtime. It'll create an instance of a point history, and then make another instance of a history.
Yes, you have two different instances.
Does that mean that it takes up twice the space in memory to use this method as opposed to just using extension and changing methods and such?
So it's like I take a house, I build an extension right next to it, they're next to each other, or I build a house, I build another extension here, and I have to walk to that house through a pointer. The space is the same. In fact, this is more flexible because the extension may not fit in my plot. Okay? Whereas with this has a, it can be somewhere else. So when you have to find space of the memory, you have to find a smaller chunk. When you have you have to find a bigger chunk when it extends than when it doesn't extend, because in the other case you say, okay, I put this object here, I put this object here. They can be in two different parts of memory, because the instance variables of an object have to be contiguous. And so it actually makes memory management easy. But you have two different instances. That's a very good point. And that gives you a lot of flexibility. One instance can be on one machine, another instance can be on another machine. So it was like this. So first, languages didn't have inheritance. They were called object-based. Then they had inheritance, so they became object-oriented, and everybody was gung-ho on inheritance. They just did inheritance everywhere. And they did it wrong in many ways. So that was Java 1.0. They had the whole toolkit based on inheritance. And then they started thinking, and this is how sort of the whole community was evolving. Hey, we're using inheritance where it shouldn't be used. And let's use delegation. And right now, you know, it's like whenever somebody uses inheritance, they say, are you sure? Are you sure you're not losing flexibility? And in my own case, wherever I've used inheritance wrongly, where it didn't make much sense, but I was just lazy, I didn't want to go and do this forwarding, I regretted it and I changed the delegation later, because when code evolves, you want the flexibility, and you see the flexibility. One flexibility here, that your add element method may not have the same signature. And again, in the scanner example, I told you guys do it without inheritance, and I hope some of you did it with delegation, where you define the new scanner and had it linked to the old scanner, and you just change the interface. But we'll give you more practice with this in the next assignment, and let's stop here. More boring now, and look at code. So we had a counter, and we had a method add and get value in it, and a variable that changed it. Okay, this is what the counter we had originally. Then we said, oh, we got to define observers about it, so suddenly this thing became much bigger. And I was not very good when I did the model view controller lecture. I did not reuse the code. Okay, so I repeated everything. I had the observer history, and my add when they notified, my get value return counter as before, and so on. Okay, so I duplicated all the code, plus I added something more. Okay, this is like string database versus string history. I should have really inherited. Okay, so I should have gone and said observer counter extends the counter. I should have said super.add amount. Okay, then the add occurred and notified in my add. And I don't have to have a get value now. And I have an add observer, remove observer, and notify observer, which is my additional methods. This is my inheritance approach. Now, what would be my delegation approach be here? What's your name? Dave? Nate. Okay, so since you're the one who gave me the solution, I'm going to pick on you now. As one of the people. So how would I change this to a delegation? Have an instance variable of type counter, instantiate that, and that's exactly what's going on here. Okay, I actually have a constructor, and I didn't close the constructor for it, and I did this all in the morning, so I told you to expect some errors. So I should really have closed the curly brace here. But now I'm going, and so rather than extends, there's no extends any longer. I have an instance variable, and I go and ask the counter to add the value. So I'm reusing the add method rather than saying super. This is where I'm passing the ball. Okay, I don't just say, whatever I inherited. And I have add observer, remove observer, notify observer, and so on. My get value goes and calls counter.get value. Pretty much what, if I hadn't taught you inheritance, this is how you should have done this. Okay, before inheritance was invented, this is how people used to do it. It's very interesting, it's like bell bottoms became in fashion again. Honestly, this was called an object-based language without any inheritance. Then inheritance came around and became object-oriented. Okay, that was the term. Everybody was so happy. They said, you know what? Let's go back to object-based. Okay? Inheritance in certain circumstances is a bit too much. Okay? And we'll see all those reasons. Okay? But like I said, what you really get is flexibility. So, again, I'm repeating things. Class reusing code has a reference to the reused class and not isn't. So we have a reusing class and we have a reused class in both cases. In the case of inheritance, the reusing class is a or inherits from the reused class. Okay? In delegation, the reusing class has an link to an instance of the reused class. Okay? I'm just using a lot of big terms, but from the example you can see what that means. And the reusing class is called the delegator. That's the one that passes the buck. That's the one that doesn't know how to do anything. And the reuse class is the delegate. That's the one that really does things. Okay? So we'll go in slow motion. We'll go and see the differences. So in one case we extended. In the other case we had a reference to. Okay, that's one big difference.
In the delegation, the interface is
That's good. Very good.
then it extends the reuse interface, but then doesn't leave the staff not have to.
Was this a early morning mistake? Rebecca thinks so.
No, it still has the other methods. It's just the other methods called the first class.
Very good. I'm still extending the same. I have the same interface. When I define the delegate, I'll have the same method as before. I just implemented it differently. In one case, I inherited them. I'm still playing basketball. Okay, so that method remains the same. It's just that when I get the ball, I pass rather than I just. Okay. So that's the difference. So I will still have the reusing interface. I'll have the same interfaces and just provide a different way of implementing. Okay. Now, how many instances are there in this case? So when you have a reusing class, be a subclass of reuse class, and when you are creating an instance of the reusing class, how many instances do you get from overall? One. That's not a trick question. In the second case, how many instances do you get? Two. You really got two players versus one player. That's the analogy again. Okay, because you have a link to an instance of the other things. Okay, so you have one instance. That instance, that's a question that you were asking me last MVC last time. That you said, aren't the superclass variables shared among multiple instances? No. Each instance gets a copy of the superclass. Yeah. Okay, so I have one instance here. If I create another instance, that will get a separate copy of the superclass variables. So the superclass variables and the subclass variables get all combined together into one object. Whereas here, you have two distinct objects and one sort of passing the buck to the other. And that's interesting. We'll see later. That two different objects means one object could be in one computer and the other object could be in another computer. There could be all kinds of interesting things you could do there. Whereas you cannot do that when you have a single instance. Okay? So, okay, now if I tell you, so you want a formula that takes any inheriting class and converts that into a delegating class. Let's say we want some general formula to this. If we want a general formula like that, I must find a way to convert super calls into something else. So when you have super calls in the inheritance case, what do you have in the delegation case? So in one case I call super.method. In the other case I will do what?
You usually call the other class and then add something else to it.
So you'll just say delegate.method. Okay? So where you had super.add, you have delegate.add. Okay? So you're not just inheriting and saying, okay? So if you have a reuse method M, and you have some method N that needs to reuse it. Okay, so not only do we have the notion of a class reusing another class, we have a method reusing another method. Okay, so to the implementation of method N, I need the implementation of method N. I will just say super.m there, whereas here I will have reuse method M, and I will say delegate.m there. Okay, which is again, before inheritance, this is how we would have done things. You would say delegate, you do the work. Okay, here you say super.m. So this is okay. In observable counter, we had get value, and I said the add method went and reused the add method in the previous one. This method is doing what? It's not doing anything. It's just forwarding the call. It's just a stub. It's kind of a stub. A stub is basically a method with no body, but this is a method just forwards. It's basically doing nothing, but that's also sometimes called a stub. So you have a stub in the case of the delegate. In the delegate case, what do you have? What corresponds to a stub in the inheritance case? So when you don't want to change anything in the reusing class, what do you do in the case of inheritance? Sorry? No, you don't have to make it abstract. You just don't. Nothing. I have no get value here. Okay? That was my point. Inheritance is less work. In the delegate case, I have to go and forward every call in the interface to the delegate that I don't do anything with. Here I just inherit. That's why inheritance is so wonderful. Okay? That it does provide you with this automation. That if you have 20 methods that you want to inherit, you just inherit them without overriding. Whereas here you've got to go and forward to all of them. Okay? So if you have a reuse method M, which is not being overridden, you'll have to go and say, you have to declare a new method M. This is not N now. We have to define a new M stub that calls M here. Whereas here, you just inherit. Okay, so this is actually an advertisement for inheritance here. Why inheritance is good. Okay, because it does reduce work. So delegation is more work. So I'm going to have a class which I'll call a delegate class. Okay, you say, oh, it's getting confusing, okay, because they've got this relationship between them. But this is going to be a delegate class. Okay, so where I would call an abstract method here, what would I have to do to implement the same functionality? This method is called in the reused class or the reusing class. This method isFull is called. This is the reused class. So isFull is called in the reusing class. That is the delegator. So you basically have to call a method in the delegate, which is what we didn't see before. So the delegator calls methods and delegator and the delegator calls methods back. One of these is a call and one of these is a something that you might have heard of, response, or there's calls and call. If you've done any toolkit programming, callbacks. Okay, it's like you want some work done, so you call them and then they call you back. Okay, and it's kind of a funny thing, but it's as funny as the abstract method is funny. Okay, because you go and say, okay, I don't. The subclass says I can't do this, so it calls a method in the superclass. Says, well, I can't do it completely. I'll call a method back in you. That's exactly what's happening with abstract methods. It's kind of a callback, but it's done through abstract. Okay, so things get a little more confusing. So what happens here? You're editing this, and what happened in the delegate case? You replace these abstract methods, so you do something like this. Now, my delegate class must know about the delegator. Okay, so the delegator is a string history. Okay, this is a collection, and the delegator is implementing the interface string history. It's a string history. Remember, so we're going to use interfaces for typing. So far, the delegator had a link to the delegate. Now a delegate must have a link back to the delegate. It's going to do a callback. Okay, if you're going to call somebody, call some 800 number, and you expect a call back, you've got to give them your number. Okay, so this is like going to the 800 number, you want your job done, and they say, you know, I'm doing this job, but I need this from you. Okay, so they call you back. Okay, so you have to leave your number. Okay, that's what you're doing. So that you're saying, this is me, I'm of type string history. Okay, and it said, okay, if you're a type of string history, you better know what is full means, and you better know what unchecked add element means. Okay, so when I'm doing my work, I'm going to make a call back to you, get this information from you, and we'll work in this fashion. Okay, so this probably helps you better understand what abstract methods. Okay, you call somebody to do your work, and they call you back. Now, who's the server, who's the client? When you call an 800 number and they're calling you back, I mean, who's serving who? Are you serving them or are they serving you? It gets a little confusing, right? But can you say that one party is serving? Or is it a symbiotic relationship of some kind that, you know, we're both working together, like in a basketball? What do you think? So in some sense, the callback is doing the serving, right? So would you call?
And they're serving you, so you're just giving them the information they need.
They're serving you.
You.
You initiated the call. They didn't. If they had their choice, they wouldn't service your calls at all. You know, they all want to make money and not process your call. It's you who start initiating. You've got a request, and they just say, okay, if you want me to do your work, you've got to give me this result. That's why call and callback is very clear. Who initiates? The person who initiates is the delegator, is the one who makes calls. The one who goes and does some work to fulfill that work for you. It's not, you know, they don't depend on you, you depend on them. Okay? Is the callback. So that's why these two different terms. And that's why there is still a very clear delegator relationship and delegate relationship. It's just that there's a callback. Okay? So delegate class must implement. Okay, now here's the difference. In the case of abstract class, we said, now this is not a standalone class. It's not a specification of anything really. We need an implemented interface. It will be inherited by somebody that will implement an interface, and it's that interface we will use to go and actually type concrete instances. Now we've got to do some extra work. You know, whenever we use delegation, we've got to have interfaces for the delegates. Even though they're not standalone, even though they'll never be in a program alone, there'll always be somebody who'll have a link to them. Okay, so this is one difference. Delegate class must pass reference to delegator. Remember, in the inheritance case, there's only one instance. Okay, so it's, you know, you call the abstract methods in the object in which your methods are. Okay, the objects which is inheriting the methods, or whose class is inheriting the methods. Here you got two instances. You got to leave the callback number, and the callbacks are invoked in the delegator. Okay? Do you understand? I'm just repeating what I... Now, so that was my delegate class. What about the concrete class? This is the concrete class in the case of inheritance. In the case of delegation, how would it be different? I'd have to have a link to the delegate. Plus, I've got this red box around here to say that something else must change. The delegate must call is full and add element and unchecked add element, right? Is there some small way in which these two methods must change now? They have to be public. The abstract methods could be non-public. Okay, as long as we are going to follow, because this is calling back. Okay. So this is the situation. In the case of calls, whenever a method called, if method n needed method m in the superclass, we just said super.m. Okay, and that said delegate.m back if n needed n. In the case of callbacks, it's kind of more complicated, right? The reuse class has a method m that it needs to do its work, it needs to go and call method n. So how is it done in the abstract class case? This is literally more complicated. It goes and defines a stub or an abstract method called n in its class. That n actually stands for a concrete method, so it just goes and says this.n. It can't say sub.n. Okay? Because it doesn't know what the subclasses the method will have. So it just says this.n. N is an abstract method, which means it will get called in actually the subclass. So that's a way of sort of saying going down. And this is how you get reuse method m calling reuse method n. Whereas in the delegate case, I mean, it's just more direct. Okay, you just say delegator.n. You just call back. So here's the question we have to answer right now, because this is all getting very confusing, these calls and callbacks, who's the server, who's not the server. And from the 800 case, you know, the analogy works. But because the reused class is calling a method in the reusing class, does the reuse class get bound in some way to the reusing class? That means the reuse class can only be used with this reusing class and not with any other reusing class? No?
We have multiple classes that inherit the abstract method and implement the term as long as they fit the same interface.
As long as we have interfaces. As long as we don't use classes to type. Okay? There can be all kinds of reusing classes that can use that. This is much like the model calling a method in the view. The model doesn't know what the view is going to do with that method. It says, you know, you need to be told about this. And you do whatever your thing is. It says, I'm going to do this callback in your thing. Whether you go and give me this social security number or this birth date, I don't care. That's your responsibility. I just need these two pieces. Okay, so it is not really bound in any way. Its functionality doesn't depend on what exactly you do. Whereas the other way around, it is true. Okay, how the reuse class behaves does influence what the reusing class gets. Okay, so this whole notion of delegation and interfaces have gone together in Java. I've told you always define interfaces, right? There are all these good things that can happen. Okay, but when it came to delegation, you really couldn't live without it. Maybe other times you can probably live without them, and maybe there's some future benefit later. So that's what really happened, that these two things went hand in hand, and you'll see that delegation and interfaces are related. Okay. Again, it's clipping off. Has that been happening a lot? I didn't realize. Did it happen last time too, that you didn't see the whole thing? Okay, so I've got to place another call to these guys. Okay. So delegation depends on interface. So calls from reusing class to reuse class. Callbacks, calls from reuse class to reusing class. Okay? And this is not, this is again repeating what I said, but it's good that there's no symbiotic relationship here. It's not that these two things are working together to solve the problem. Okay? Delegate has no idea what the callback does, it's independent of. And model notification is an example of callbacks. So you'll hear this term a lot, callbacks. Okay? This is done to service calls. But you have access problems occurring with callbacks. And the problems are even more if you access variables of reuse. So here's an example. Yeah, again, I hope I modified the stuff later, but let's see. So I've got a string database that extends a string history. Okay, and what it does is access directly the variables of string history. Okay, that you can do that, right? You can inherit the variables of the superclass. In the case of the delegate case, what will happen? to change. So where I was doing dot size, I'd have to do what? Call the size method. Where I'm doing equals contents index, I'd have to do what? You guys remember what string history provided to access elements? You guys have been doing that in your collections? Element add. Okay. So I can't access the variables directly. Okay. So again, we are seeing now why inheritance sometimes is more efficient. So we have all these problems right now. We have to do something about this. And I guess I did this right this time. So following. I have to have the delegate. Do what I've always told you not to do. So the delegate I always do. But, you know, and I'm calling dot size at index. And this is where we get into trouble. You just type it using a string history. My clear in the previous case just said, and now you can with abandon access all the variables. Zero. That is why now you see why they have method that we define in the string database. We didn't have that in the string history. There are times when you want delegation. I'm the one who's supposed to define clear. And I can't you want to access the variables. You just put them in the same. So we'll have and then it just works. Clear in the string history. You know, so you lose some flexibility. You're bound to a string history right now, but that's no worse than in the inheritance case. There also you are bound to the superclass, a particular class. Okay, so you're no worse than delegation inheritance. Plus, you'll have some of the benefits of delegation, which we'll talk about. Okay? So this is a good compromise. It's better than inheritance. It's not as nice as the previous solution. In particular, have to add this method. But that had its own problems. So this is why programming is such a decision-making process. That is a subclass of that. And that is the one that can be used. It's method. So because these were not made private, if these variables were made private, did I really have to call methods back in another class? Can I access variables? Where they're saying, I don't care, you're in the same package, the same that's not a good thing to do, but I really don't want you to see these variables. Sure. Okay, and we didn't do that. No. And in that case, you couldn't have inherited them either. Sorry? So classes type and accessing non-public variables in the same package. That's what we use. Okay, so properties. Okay, if I make it properties, then I'm exposing this stuff, right? So I could have had a get size and set size, which becomes, we don't want that because we don't want other classes to do that. Only we want this class to do it. But remember, so there's public variables, there's protected, and there's private and default access. So you guys remember what the difference was between these? It depended on whether the two classes were related by an is-it relationship or they were in the same package. So it's not as bad as I'm making it out to be. Supposing a string database and a string history really are very intimately related to each other, you can put them both in the same package. Okay? If you put them in the same package and you do the So callback methods must be given public access if interface types the delegator, can be given protected default access. Okay, this is basically repeating what I said, and this is just when you're studying, you have this text to look at. So let's look at all the bad things that delegation is. you need to instantiate multiple classes. Okay, in one case there was just one class. You just instantiated the most specific class, and everything else you inherit. Here you've got to gather all the delegator and all its delegates together, make it into a composite object. Here I gave you a boombox scenario. You see that you can just buy a boombox and take it to the beach. Or you can buy these 7 components that you hook to each other, and it probably won't work. Okay, and you have so it gets complicated. And you guys know of any piece of software that just has a lot of things collected together that you use? That you certainly use in this class? It's all composed together. Eclipse. Object editor, I'm trying to make it. Okay, I wish I could boast. Okay, Eclipse. It is, you just put in plugins and you combine things together, the whole world's contributing to it, and it's kind of working. So, in fact, but composition is not easy. In fact, I'm right now reviewing a paper. I don't know what the punchline is, but it's talking about the effort users put in to get all the plugins together, working together. Maybe it's easy, maybe it's hard, I don't know. But at least we guys don't do much customization, so it's not an issue. But if you were to do customization, it would be a problem. Okay, so you need to compose instances, which is a real pain. You need to define stub methods for things that are being forwarded. You have access problems. And then you have a non-standalone class like that, a collection, which didn't do anything on its own. It always called back. It just couldn't exist on its own without the reusing class. Then you have to define interfaces with it. And interfaces is a pain and everything. By the way, Eclipse does make it easy to. Anybody tried that? Extract interface from a class? I didn't tell you about it because I wanted to know what interfaces are. But you can actually go to Eclipse and say extract interface, and you can click on the methods, and automatically those methods get put into interface. Okay, so it's nice. But so, like I said, I wanted you to know what was an interface. Otherwise, it will all be magic to you. But you can use it. Okay, every con typically has a pro also. So need to instantiate multiple classes. So that's a pain because you've got to compose them, and that's a good thing because so is it smaller, more maintainable classes? I mean, in the inheritance case also, I kept inheriting it, and they were all different classes. I didn't put them all in one big class.
Right, but each thing is you have a big hierarchy. Each of it is doing different things. And in this case, you would have 2 things that are doing more specific things.
But we saw they were almost the same thing. The one-to-one correspondence between methods in one class and methods in the other class. There was dependency through interfaces. There was dependency through classes. And that's the key. Okay, maybe it's the size is same. The size is in fact smaller in inheritance. It's just the inheritance versus class. So the boombox versus composing your own stereo system. Why do people compose their own stereo system? Because they have a lot of time at their hand, or because more of the object comes in?
They can get very specific things out of it in the background.
They can get specific things.
Sound quality better usually for cheaper. I mean, if you're actually talking about boombox stereo and stuff.
No, well, let's just say that not boombox, but a bit, something that's all given to you, supplied to you by one manufacturer versus you can decide to use this or that. And if a component breaks down, you can just replace it, right? Or if something new comes up, if there's a new DVD format, just replace the DVD player, not the whole thing. Flexibility. Need to define stub methods. So if I want to reuse an inherited method, in the case of inheritance, I just don't define any method. In the case of delegation, I forward the call. What's the pro there? What if I don't define the forwarding call?
So you can choose which ones to delegate and which ones not to.
Which one to reuse? In the inheritance case, you get all the methods. If you guys have ever used vectors array lists, And if you want to create your own list, if you subclass of array list or subvector, you get all the methods. Even if you want a history, where you don't want to remove something, you get the remove method. Now what can you do actually if you don't want remove to do anything? You can, the start method it doesn't call super and just does nothing. But it's, it's doing nothing. There's an empty method there. Whereas here you can pick and choose which methods to have. Okay, access problems, well, there's no pro there really. And need to define special interfaces for non-standalone class. Well, interfaces always give you more flexibility. Okay, so composition through interfaces is much more flexible than through. Okay, so let's go through these pros in slow motion. Okay, so I've got a reusing class. It is using some reuse class. Now there's a new and better way to do that. Okay, so my reuse class has been superseded by a reuse class 2. What do I have to do? I have to create a separate reusing class 2 that inherits from reuse class 2. Because inheritance is in my class declaration. So if I want to go and use reuse class 2, I have to go and create a new class that inherits from that class rather than the previous class, if I want both versions to exist at the same time. Okay, in the case of delegation, so I've got two versions here. My reusing class can remain the same. Okay, as long as the reuse class 2 implements the same interface as the reuse class 1. This is the great thing about delegation interfaces being tied together. I don't have to create another version of the reuse class. Okay, this is a very, very big pro. I mean, this is, I'm telling you, I'm sermonizing, use delegation at times, and I cheat like all of you. I'm in a hurry, and I say, let's just use inheritance. It's so much easier. And then I always curse myself for doing so, because when I have to change things, I have to then, rather than at that point that I go and use delegation. I don't want to create reusing class 2. So I'm often need driven, but I've always been burnt by not using delegation when I really should be. And just to make this very clear, so let's say our counter. We want another implementation of the counter, resetting counter. Okay, if there's overflow, if we go up to max int, which is the last biggest int, I'll just reset the counter to 0 rather than give some error. Okay? And this is just a different counter. And if I want to reuse and change it, yeah, I changed it. So I'm calling it now an observable resetting counter rather than observable counter. Okay? And an observable counter and an observable resetting counter are identical. The only difference is that they inherit from different classes. Okay, I've repeated all the code in here that was in the previous an observable counter. Okay, because I need to now inherit of some other class. So if I want to both be around, I have to create 2 duplicate versions. And this is where you see the power of delegation. Okay, that you don't have to go and buy a new boombox. You can just substitute the components. Okay, people buy that? And in the delegation case, what happened? My observable counter just took the counter as an argument. Okay, so we have one observable counter, and this is the interface, and I can assign that to a counter or a resetting counter, and my observable behavior works. Okay, and this is not something that I've just come out from thin air. In Java, there is a class called observable. Okay, and you tend to inherit off that, and inheritance creates all these problems. Okay, and so they later went to delegation because you can substitute that. Okay, delegation goes hand in hand with interfaces, like I said. So again, to just emphasize the point, inheritance requires another implementation of the reusing class that duplicates the methods of the original reusing class. In delegation simply requires a different object to be assigned to the delegate variable. Okay, so correct the grammar here. Okay, in delegation, my reusing class can reuse multiple reuse classes. What's the equivalent inheritance situation? So I have a class that needs to reuse 2 classes. In inheritance, I just have a link to these 2 classes. In the inheritance case, also I want the same size classes. I don't want to combine classes with them. So I'm going to create 3 different classes, but I don't use has a relationship. I'm going to use purely is a relationship. What would I have to do in Java or other? Sorry? Have a hierarchy. So what would the hierarchy be? The reusing class would be a subclass of.
That would be a subclass of 2.
Okay, I'd have to do something like this in Java. Okay, in C++, I could actually have multiple inheritance. So all reuse classes must be in linear chain because Java supports single superclass. So, so what's wrong with that? Doesn't. So you can't, if you want to use reuse, so does that create a problem? Firstly, does it, when you say inheritance is reuse class really a reusing class? I mean, they're independent of each other. At force, is a relationship between 2 things that should have an is a relationship. And this really means that wherever reuse class 1 can be used, reuse class 2 can be used. This is what this inheritance tells me. Remember the is a relationship? You can use one class, you can use the other class. It just doesn't make sense sometimes. By the way, have you done any example in class where we've used more than 2 classes? Any design pattern we've seen recently? MVC. So let's go and see what happens with MVC. Okay, and this is doing MVC with inheritance. You see the code is very clean, quote unquote clean. Okay, it's much less cumbersome. Okay, and we have to go and really debate as to why we shouldn't do it this way. And I kind of gave you the answer to the question last time. But if I have a counter as a model, okay, I want to create an observable counter with console view. I do something like this. I override the add method. Okay, I call super.add, and then I go and say append to console get value, and append to console goes and prints. Okay, this is the same thing done with inheritance. Whenever you do an add, you want to print out the value. So we trap the add method, okay, and then call the display. Okay, so my view is actually much smaller than before, and there's no notifications, nothing, because you see how the controller. So now if I want to add a controller, what should I do? So the controller is going to process input of some kind. And in response to process input, it's just going to go. It's going to get the value to be added. Okay, so let's just see what's going on. Okay, no, I'm going another level now. So I'm adding a J option view. Okay, so we want to show it not only in the console but in the option box also. So what do? I trap the add method again. I say, okay, console view, you do your stuff. Console view goes and says, counter, you add the stuff, I'll display things. And this says, after the console view has displayed, I'll go and display this. Okay, so you see how inheritance is working. And this is not a far-fetched thing. This is how things used to work, by the way, a lot in Java. Okay. And finally, I have process input. And process input goes and just calls add next input. Add goes and calls the add in the J option view, which goes and calls the add in the console view, which calls the add in the model, and then they all go and display afterwards. No notification, no registration. This code is much simpler. Okay, this is kind of the solution you were aiming at earlier. So, what are the drawbacks here? We went through some of them when I answered the question in MVC. You can't just have a J option view on its own. Okay, so we got it right now. So I added the J option view and then I added the control. And the question Rebecca asked, so what if I want something without that? What if we want user interface without J option? Okay, what you have to do is create a new class, a console view and controller, and then you can make a J option view a subclass of that. And then what if you want something else? So this is not fundamental, and you sort of see this real problem here. This is my new controller at the bottom of the hierarchy. This is the previous controller. The code is identical. It's just that the subclass, the parent class is different. Okay, so again, you're repeating code just because you were bound in your code to the superclass, and you couldn't just use you couldn't just use the a different delegate. Okay. So in the delegation-based MVC, this is great. We have has-a links. Has-a links can be given null or can be changed dynamically. And I can have another interface here, so we can just, we can compose a stereo system as we want to. Whether we want a DVD player or not, it's up to us. We aren't burnt into it. Okay. Now, in the case of inheritance, you have one instance. Okay, so we didn't compose them. We have one book. In the case of delegation, we have multiple instances. Can you see this relating to distribution somehow in a distributed world? And I kind of said this before also. So, in a distributed world, how is the distributed computing different from non-distributed computing? Have you guys heard the term distributed computing before? Server farms. Anybody use Google Docs? How do you think Google Docs, can you relate Google Docs to MVC somehow? So, who's used Google Docs? So what do Google Docs let you do? Okay, so shared, you can have, yeah.
Basically, you have kind of a remote document editing application that you can use from anywhere, and you can let other people get your document what kind of collaborating for.
So I can have my browser I'm editing a Word document. You're editing a Word document. My changes go to you, your changes come to me. Right? So if I scroll my browser, does your browser scroll also? They're not coupled. But if I change the document, it gets changed. You think of the browser as a view, and the document itself as a. So that's collaborative computing. That's my research area, and a long time ago, that's the kind of architecture I created just to support this. And then I was telling you, this guy Ralph Johnson told me what MVC is. That's MVC. I didn't know what MVC is. Okay. So this was just a reinvention of MVC to do distributed things. So data and methods of both classes at one location. Okay, that's how they used to do collaborative computing at that time when I was thinking of these things. Okay, you would have any of you used WebEx or live meeting? You heard of them? Screen sharing systems? Screen sharing systems? Or there's something called Unix screen?
Well, yeah, the terminal application, you don't have to say virtual terminal.
So you guys, have you done remote desktop at all? Screen sharing is nothing else but two people doing remote desktop at the same time. In fact, in Microsoft, they started a system called NetMeeting, which was collaborative, which was, they converted, it was too complicated for them, so they converted that into remote desktop, which was just, either me on this computer or me on another computer, and then they took that code and made that into collaborative. So they're very closely related to each other. So that was the inheritance-like thing. You have just the whole code running at one place. The scroll bars and the document all running at one place. I scroll, you also scroll. Okay. Here, with the model view controller thing, you can have the model at one place and the views at different places. Okay, so it can be in two different locations, client server. Okay, so any of your games, you guys, all your games where you can shoot at something and somebody else can shoot at something else and you have different views to it. That's all model view control, distributed delegation. So this is just summarizing again. So can change reuse class without changing reusing class, multiple. I think I've said it all, and I said it recently, so I'll let you guys read the stuff before your exam to understand things. But this is pretty much reiterating what I said before. So the question thing is really that this is it's a tough decision. Whenever you have to reuse, think a little bit. Inheritance or delegation, which of these things apply? And let's go and give you some examples. So inheriting is a bad idea if a reusing class has a with in its name. Okay, what were the names I gave? I said a counter with console view. With. With means something, I contain something. Okay, so that console view is contained in a counter or vice versa. So if you have to name your classes with then it's really means that you should use delegation. If there's more than one way to do inheritance, so controller can be subclass of view, or view can be subclass of controller. There's really no fundamental relationship. That means it's not inheritance. Okay? If some of the inherited methods are not used, so I talked to you about vector, which I'll, if I get time, we'll talk about that in more detail. It's got zillions of methods. It's a very generic, reused class. But you might want to create a history where you don't allow deletes. So, what do? Do you add stubs there that don't do anything? That's just a bad idea. So, and there are times when the reusing class must have the exact same methods as the reuse class. But still, they're not interchangeable. They're philosophically not interchangeable. You just have the same methods. Okay, you might have two kinds of iterators that produce characters, but they really shouldn't be interchanged. And with interfaces, you have that problem to some degree also, but with inheritance, you have even more so. Okay, so let's take an example here. I've got a Cartesian point. Okay, it's got x and y and get x, get radius. I want to create a square which needs a point. I can either do delegation or I can do extension. Okay, so here I've got a side length. That's all I need to add to the point. And I just implement the get side length. Everything else gets inherited. This poor guy is doing delegate, which means he must go and define stubs for all of these things. He says center.get x, center.get y, and plus he has to do side length. So which would you use here? Delegation, because square is not a point. So that's philosophical. From a practical point of view, can you think of a circumstance where you'll say, oh, I'm so glad I used delegation? So we had a Cartesian point and we had a, supposing we need to use polar point, because that calculates the polar points more accurate. This one rounds off. Yeah, we really need to work in terms of angles. Then we can substitute. Otherwise, we have to redo the code. See, that was if you guys have been reading email, there was a question asked, I have a simple upstart, I have a complex upstart. My complex upstart is a subclass of a simple upstart. Okay, maybe a simple upstart is really a circle, and your complex upstart is a circle plus hands and so forth. So both upstarts have a head. They should have a link, has a relationship to the head. It's not that, a complex upstart is a head. The head with arms and everything else. Okay, so this is an example. This is something and in textbooks I saw this done through inheritance. Okay, and so this is a mistake people even professionals make. So square is not a Cartesian point, and we cannot use a polar point without reading. And just to tell you that I told you that, look, I've learned through my mistakes, and I've cursed myself for not being pure. The whole community has done. Okay, so Java 1.0 used inheritance. Okay, in its toolkit. So here's how it worked. Supposing you want to use a widget class, a button. Now, when you use a button, what you want to know is when the button was pressed, so that you can do something like maybe increment a count. So what you had to do was create a widget user that was a subclass of widget class. Okay, and this is, I'm telling you, I haven't told you guys, you haven't had the opportunity to learn toolkits in depth because you've been using object editor. But many of the concepts and toolkits you are covering. So I told you about MVC, the observer thing. Here's something else that you're covering about toolkit that's interesting. Okay, so what would happen in the inheritance case? A button gets pressed. Okay, so the button class would go and say call a method called process action. Process action would call an abstract method called action performed. Action performed in your class would be subclass, and you would actually go and bump up the count. This is a callback. See, what you really need is a callback. Because the button is pressed, The button is the 800 server, but it needs to tell you that something got pressed. It's like the airline notifying you that your plane is late or it's on time. You get a call back. So you basically went and did a callback here, and that was the concrete action performed. And that was 1.0. Then they decided this didn't work very well. And they went and did it this way, where you just call delegator.actionPerformed. You just made a callback to a listen. This was really observer pattern. Okay, this is 1.1 and later. So they just changed. There was a very, very big change. A lot of programs didn't work after that. Okay, this was revolutionary in those times. And this is my example here. So I made a counter controller be a subclass of button. And in there I defined an action performed method, which was called by process action in the button. And it that way. And this is the delegate case. And now a counter controller, is that a button? It has a button. Yeah? So but this is how you used to do it. And that's not just a small talk. I mean, not just in Java. This is how Smalltalk did it too. I always have told you Smalltalk is wonderful, but not that much. Okay? They inherited this thing from Smalltalk. And the reason they went and changed this thing was that in 1.1 they realized that some programs might want to use swing J button and some might want to use AWT button. So this way you had the flexibility, you could use either and you didn't have to be bound. Okay, so you just see that this changed. This was something that actually there's a big change in it. Okay, you guys understand what's going on? This is just abstract methods being called, nothing different. It's the whole notion of the button being the server, you being the client. In one case, the client has to be a subclass of the server, which just doesn't make sense. Think about it. And in the other case, the client has a link to a server. It can go and use this server or that server. Okay? And just to tell you that it's not as if they've really fixed all problems. So if you want to draw something, I mean, how do you think Object-Oriented draws on the screen? It takes a panel from swing and it makes a subclass. It should be retained. The panel goes and calls retain, which calls an abstract method called paint. An object editor just goes and subclasses that and goes and draws and paints on the drawing. This is how, if you had to do the drawings yourself, this is what you do. So even today, to customize the toolkit, you have to sometimes go and create your application panel as a subclass of panel. Why did they not change this? Well, you know what? Swing and AWT share this single panel. So they didn't have a need for substituting these two things. So that's the system. That's my theory. I'd like to know more profoundly. So, but as it turns out, I want to use Object Editor and I want to run Object Editor on top of many toolkits. By the way, do you guys know what the various toolkits Java has? I told you Swing, and I told you about AWT. Anything else you guys know? Are the Java toolkits you could use from a Java program? Java usually has models, doesn't have toolkits. So the object editor widgets, do they look the same as Eclipse widgets? You know what toolkit Eclipse uses? Something called SWC. Okay. So they just didn't like the Sun's version, so they decided they would find more. It's SWC. So we'd like object editor to run on top of that also. Google has its own Java toolkit. Anybody know the name? It's also a Java tool. So ideally, we'd like to be able to draw on either of these panels. So you get into trouble and you really want a delegation solution. It doesn't exist, so that's what this is saying. Okay, so main problem again is that widget user could not be subclass of any other class because of multiple inheritance. And also with delegation, when a button is pressed, you can have multiple classes, multiple objects be notified about it. Whereas with the inheritance thing, you had only one person notified. So there was all kinds of issues. Widget implementation can be switched with delegation, and the observer concept was supported in both approaches. Anybody use threads, by the way? So this is interesting. Threads are very crucial. Another question. So in terms of your project, what's left? Undo, redo, and anything else that's left that you'd like to do? Multiple computer, you want to do that? And animate. And I've had students come to me and say, when are we going to do animation? Well, to do animation, we have to learn threads. Okay? And we'll hopefully look at threads. So I have only so many classes left, and I'm just wrestling with what I should shove down your throats, before you leave. But threads is something you will learn in great depth in operating systems, but unfortunately, according to me, operating system is not a required course. So you might go away with a degree here without learning threads. So I think that would be a problem. So at some point, I'll talk about threads. How many of you really want to do animation, by the way? I'll make it 2 or 3. Not that many. So maybe I won't do it. We'll see.
It's going to be observable. If you're not going to be, what are we going to miss by doing threads?
Okay, what about undo, redo versus threads? Actually, undo, redo is going to depend on threads because they use something called command objects. But undo, redo is also optional, right? That is actually, in my opinion, more optional. So that I might even make extra credit. But it'll be just more kinds of refactoring. Okay. So think about it. I might just do threads next time.